So your interviewer leans in and says, hey, our LLM feature takes 8 seconds to respond and product wants is under 2 seconds. How do you get it? Right? So this 8 second, 2 seconds are just for examples. It can be different things. Okay. Basically, you want to reduce the time taken for you to respond. Now, in this example, right, 8 seconds does not really seem much, right? But imagine that you are sitting here and you are querying something and you're just waiting for this to spin around for 8 seconds. So it might be a little bit frustrating, especially for things like the banking systems, right? So 8 seconds may feel really big and 2 seconds may feel like magic. Okay. So now the interview is basically trying to ask you this question, and if you go ahead and say like, we just use a faster model, right? So faster model, faster response. Okay. So that is only partly true. Okay. So the real answer basically touches a lot of things. So basically it touches things like the prompt, the architecture, the caching layer, and sometimes even the entire way how the request is served. So let's actually build this. We measure using real numbers and see where these things go. Okay. So what the interviewer is actually testing you, right? So the interview is basically asking this question because the interview knows that there is no one correct fix for this. So what they are actually probing is like whether you understand like where the latency actually comes from in the LLM system, right? Because making it fast is not really a skill, right? Knowing that latency is really sum of several separate costs. So there is the cost of your prompt, right? So and then there is the cost of the output tokens. There is the cost of generation, right? The code generation, all that. So there is a lot of things. All of them, summed up together is where actually the cost and the latencies. Because if you're doing like 10 things, right? Each of these things will actually take some cost. Each of these things will actually take some time, right? So all of them together will give you the final cost and the final latency, right? So fine. So we need to understand all of them. So imagine that there is a small support tool. So what we do is a user asks a question. So when user asks the questions, it will let the LLM, right? So now imagine that you have huge prompt that it is actually hitting the LLM, because the user question is a prompt, then you will have your system prompt. So then it will basically go and hit your LLM model. And suppose you are using an expensive model. So what happens with the expensive model? It basically thinks a lot of, it takes a lot of time to think, right? Because it has to do a lot of tasks. Okay. So now your system prompts are there, huge system prompts are there, your expensive model is there, which actually takes all this huge prompts, and it is taking a lot of time to think. It is giving you the right answer, but it is taking a lot of time. So what happens in that case? When you sum up all this, you will get a slower response. Now what is the thing that we need to look at here, right? So now instead of just giving a theoretical answer, so what I'm going to do is I'm going to simulate this. Okay, so I'm going to simulate this. So here I have a simple use case here. All right. So what I'm going to do is like I have the sample queries. So I have some 5 sample queries that I'm going to fire to the LLM model, and I'm going to use two different things. Okay. So two different scenarios. So one, I'm going to use, there is one way is I'm going to use a very long system. So this is not really a very long system prompt, but I'm keeping it short because I don't want to incur so much of cost, right? So real cost, because this costs me real money. Okay, so what I'm going to do is like I'm going to show you sample queries. So this is, assume this is a longer prompt, then I have a shorter prompt to this. Okay, and then what I'm doing is I'm also having a response caching. Okay, so now there are two things. So before that, again, I just wanted to show you like I'm using OpenAI model GPT 5.4 mini. This is my expensive model and this is my cheapest model. Okay, so not much of cost difference between them, but just I can show you with some examples. Right, it will actually show you some latency, some difference. So when you basically use bigger, higher prompts and everything, higher models, and the difference will be very significant, but still it is very good use case for us. Okay, so there is this knife, right? So what it does is it will go to the all of the query, right? So all of this 5 questions. So for each question, what it does is basically it will call the expensive model. Okay, so there is no caching, nothing here. Okay, it will just call the model and it will get the response. Now it will basically print you the latency and all those stuff. The optimized version, what it does is like it will basically do two things. One is it will basically, if a question is already asked, like for example, uh, if a question is already asked, what it will do is it will get the response from the cache, because it will store the response in the cache, so it will pick it up from there. Second thing, what we are also doing is, because your system prompt is fairly short, instead of sending these many tokens, we are only sending a small bit of tokens. And because it is actually using a cheaper model, it does not take that much time to actually think. It will basically give you the output, right? So these are the few things that we are doing, and then we are capturing all those details here. Okay, so at a very high level, this is what we are doing. Now when I say that I'm using a cheaper model, right, so a cheaper model is not for every use case, but you need to understand like what is the right model, right? See here, what I'm doing here is like I'm just asking simple questions like how do I reset my account password, right? So that information would already been there somewhere. So it's a simple task. So simple task, we don't need an expensive model, right? If it is a very complex task, then I would replace that with a higher models, and then I would still optimize my prompts. But since this is a very simple task, I'm using a cheaper model. So that is also something that you need to keep in mind. Okay, so I have run this. So I have this here. So what I'm going to do is I'm going to run this. So what it will do is it will basically run this model, right, in a naive. So it is taking the GPT model here, and what it is doing is for every sample questions hitting it, and it is getting the response. It is not caching anything. Okay, so now you can see here, right? So how do I reset the account? So it took like 2.62 seconds, and he got the answer. It got this question could took 2.48, this 2 seconds, this 2.5. See, relatively is smaller, right? So on an average, if you look at it, it is like 2.36 seconds. So this is good, right? But because see, we are not using such a huge prompt, right? We are using a simple prompts. We just, because we want to just show you a demo, right? We're not doing the production grade, but still you will see the difference. So if I do a optimized one, right? So you see here, I'm actually getting 0 seconds. Now, why I got 0 seconds? Because I actually ran this before, and since I have already ran this before, what happened is like it basically catching it from the cache. So I ended up with 0 seconds. So now if I basically run this again, this one, you see this, this is like 2.3 seconds, and this is like 0 seconds because I'm actually using the cache. So what I'm going to do here is like I'm going to go back. Let me just rerun this again. Okay, so let's rerun this. So this should clear all the cache. So let me just clear this up. Okay, okay, so I'm going to show you again, right? So I'm going to run this name, right? So what it does is it calls the expensive model. It will basically query each of this. It is not going to cache it, and then what it will do is it will give you the average time, and it will also give the individual time, right? So these are the individual. For this question it took this much time and all. The average is like 2.48 seconds, and I'm going to run the optimized version. Now see, I don't have the cache here, right? So what happens is like, because I don't have the cache, it is actually for the first time it is basically touching the model, and it is giving me the response. So here I have this 0.77, and if I do a compare, and you will see like from 2.48 seconds I brought it down to 0.75 seconds because I'm using the cheaper model. Now if I basically go back and rerun this again, you will see that because I have already I have already sent these questions, I have already have the answers, so I am basically having this latency to 0. But here if I run it, it will again go back and basically run the same questions again. So it is not going to use a cache, it is going to run the same questions again. So obviously it will basically cost you the same tokens, it will or similar tokens, and it will cost you the same, right? So again you will see here it's 2.5 seconds. So If I run the compare model, you will see this is 2.5 seconds and this is 0 seconds because it is using the cache, right? So these are the couple of things that you can do. Okay, so now that you understood this, right? So few more things that we need to talk about is like, okay, uh, you understood like we need to cache it and you need to use a cheaper model so that way you can reduce the latency. So now some of the common mistakes that people do when they give this interview and they answer this question, right? They probably say that, hey, no, we need to switch to a faster model, right? But the issue might not be the faster model. It might be a very big prompt, or maybe you're not using cache. So in this example, right, so even if I use the same model here, right, because I'm running the cache, it is not even hitting the model. So if it is not hitting the model, it does not matter if it is basically a smaller model or larger model, right? Because we're not encountering any cost. So that is the important thing that you need to understand, right? Sometimes it's not always switch to the faster model. It is sometimes like your prompt or your caching, that can also cause issues. So we just seen this. The other important thing is like we are only measuring the average latency. Okay, so sometimes what happens is, right, if you go back here, right, in this case, okay, so let's say, so if I'm running this, right, so there are 5 questions. Okay, now this is a very small number, so each question has some time limit, right? So one question you might get it in 2 seconds, one question you might get it in 3 seconds. Like this question you got in 2 seconds, but this question actually you got in 2.82 seconds. So when you add up all this, your latency is 2.45 seconds, but this question actually come within 2 seconds. Now, so this is where the problem could be. Like you my if I remove certain questions, like some of the questions might take a lot of time, so you need to individually go back and check those questions, because those are the questions that is actually causing the latency to go up. So we need to ensure that we check what are the questions that are actually breaking our system or spiking this latency, and address this individually. So not just looking at the overall average, you need to also look at like which are the questions actually causing this average to go up, right? So that is something which is very important. So some people also say, Lena, whatever the response we get, we just stream it, right? So it's like you put it in chat GPT and it will kind of stream the response. But that is not the good way, because see, once people are not going to read the stream response, it's very difficult, right? So and again, the question was not about like, hey, you were getting the response one time or not. The final response, what is the final response that you're getting, right? So that is what it, because this might be good small tweak, but then you'll have a follow-up question and interview will ask like, hey, you know what, we don't want the streaming because we want the latency for the final output, right? And the other common mistake people might do is like they just keep on caching, right? So let's say there is a policy document like about the refund policy, so you cached it. Now they updated the refund policy, but your cache is still pointing to the older one. Now it will become stale, right? So it will give you the wrong answer, right? So it will not hit the model, it will give you the wrong. So you need to also make sure that your cache is always up to date with the latest information. All right, so these are the things that you can do. In addition to that, there are a few other things that you can think of, right? We talked about the prompt optimization and everything, right? So we see what happens is, right. So there are several providers that will basically let you reuse the internal computation, right? So like a very long system prompt, so you can reuse it across calls. So you are not paying for it, you're only paying for, you read this prompt, so a little bit tokens. So that is something that you can utilize it, reusing a prompt. And obviously reducing the output length, like you say now, the output I don't want, like I want to cap this output to like say 1000 tokens or whatever, right? And there might be some cases where you might have different sub calls going on, like user asks some questions, you might have to call for different functions and see if these are like, this can be run in parallel. So if they can be run in parallel, run it. Obviously if they have to be in sequence, they have to be, but parallelization is also something that you can look at, right? And sometimes you need to have a optimized server infrastructure also. So if you don't have that proper infrastructure also, like we have tools like TensorRT, LLM, right? These are the things that you can use to kind of optimize. So when interview asks these questions, right, like how do you reduce the time, don't jump and say like use a faster model. So these are all the layers that we need to talk about. So this will make the interview believe like, oh, this guy actually understands how to actually look at what the problem is and how to resolve this problem, rather than just giving a one word answer. All right, so this is how you should answer. I'm sure it's going to help you in your interview questions. And yeah, that's all I have here.